So one of the fun things that we got to do this year for the conference was to do a student paper competition. And there are posters from some of the finalists out in the hallway, so I hope during coffee breaks, maybe a little after lunch, you'll get an opportunity to walk around and talk to the students. The almost uniform feedback we got from the judges was the overall quality of those, and so we really enjoyed that. So our next two speakers are going to be the winners of that competition. And so Helmut Neher is the winner of the graduate student competition. And Helmut was raised in an avid hockey town, though he didn't tell me which one. And he thrives on the thrill of hockey. He's played, watched, and due to his affinity with technology, he wonders about how we can apply some modern technology to hockey. He's currently a master's student at Waterloo, studying use of technology, and we're going to hear some about that. Can aid the game of hockey and evaluating player performance. In his free time, he enjoys hiking, board games, and attending local technology venues. Helmut.
Thank you very much. Can everyone hear me? Well, okay. So my name is Helmut Neher. In case anybody was wondering, I'm from Timmins. So way up north, a lot of snow, cold. I think it's still snow. I haven't been there in a while. So my title is called Pose Estimation in Hockey Videos Using Convolutional Neural Networks. Now this is the title of the paper that I submitted, but if we were to dumb it down or to put it in lay terms, really what we're trying to do in this paper is evaluate the capability of a hockey player. Usually in hockey analytics, you take statistics and you evaluate the effects of a player and how that affects the team performance, or even as a player as an individual. And so what we're trying to do is understand how we can analyze as coaches, analysts, or even scouts to figure out which hockey player would be good or beneficial for a team. And so what I'm going to be doing, instead of applying it to statistics, I'm going to be using hockey videos and finding a new way to evaluate hockey videos in order to understand the capabilities of a hockey player. And so there are definitely some challenges when it comes to evaluating hockey player performance. And so this talk specifically will talk about just players in general, not goalies. Goalies are definitely a different problem and they're much harder to solve, especially when it comes to video. Just mostly because of their padding and it's difficult. And so there are three challenges that arise when we're trying to get data. One of the facts is that when you're in the OHL or in lower level leagues, you have to actually be there at the rink, taking the video. You have to manually derive the statistics yourself, if there are any statistics available. Another problem that we see is that data sometimes, just as was mentioned by Sophie, is that hockey is very interdependent. A lot of players, when it comes to statistics, it's all team-based rather than line-based or even player-based as well. The points reflect a player, but it doesn't necessarily mean that the point system is independent for a player. And so another fact is that there's just a limited amount of data. There's only so many goals that arises. Even just the Ottawa game with the Rangers on April 29th that had 11 goals. That's a lot of goals for hockey, especially in the top leagues. And so I just wanted to quickly show some of the different previous works that people have attempted to do and have successfully done. One of them is by Rob Bowman, who did the LSD, who modified that. Michael Schuckers also did the modified Corsi, the digger in the floor, and then also a few others by Andrew Thomas and Lisa Keel. And all of these incorporate statistics, which are very valuable in understanding a hockey player and the capabilities as well. And so what I'll be doing is taking videos and seeing how we can interact with videos and what kind of data we can get from them. And so the data that I'll be getting that we have tried to identify is called pose estimation. And pose estimation is estimating the locations of limbs and joints of each player. So if we are able to take a video or an image of a hockey player and determine where the limbs are, we can gather more data. And some of these data could help us identify, for example, the different actions of a player. We can know when a person's shooting, when a person is just standing there with their feet straight on the ice, doing nothing, or when they're speeding, when they're skating as fast as they can. All these things we can assess and we can identify. And so the picture here shows Sidney Crosby, and then it shows all the different joints that we are trying to determine. And so with hockey videos, you have to use a computer algorithm. You can't just manually annotate them. You can't just pick and say, okay, this is where this joint is, this is where this joint is. We tried doing that. It takes an hour to do 100 images. It's a long time. And so what we're trying to do is try to develop a computer algorithm that can essentially know where the joints are. And then by knowing where the joints are, then we can get more data and then spread it out and try to find different ways that we can evaluate hockey players. And so the computer algorithm that we're going to be using, that we have used and implemented, it's called convolutional neural networks. And so convolutional neural networks are part of the artificial intelligence bubble. It's associated with machine learning, all these buzzwords, deep learning, deep networks, all these buzzwords that you may have heard in the media. And so, but to dumb it down and to bring it to a simple concept, it is trying to imitate the learning process of the brain. And so if you were to be a biology student trying to understand the different bones of a person, how you would do it is how would you understand or know what the name of a bone is you would memorize it. You would look at the bone and you would repeat the name of it 10, 50, maybe 1,000 times. And so that's exactly how a convolutional neural network works. So a brain consists of 1 billion neurons, and they're all interconnected. And each neuron receives a specific input and then outputs a signal to the next neuron. And so that's what the picture of the brain on the left side indicates, is the amount of neurons. And on the right, the image is what a neuron pictorially looks like, I guess you could say. And so based on these connections, and then based on the signal strengths from each of these little units of neurons, a person can actually learn. And so that's how it is with the biology student. He would essentially learn. He would memorize as much as he can, and what he's doing is he's increasing his neuron, increasing the strength or the weight of the neuron. And so that's exactly how this algorithm essentially works. It takes a whole bunch of it takes a corpus of images that are already annotated, so they have all the joints already located, and then the computer algorithm determines and looks at it and modifies its own specific mathematical neurons, which are just mathematical functions. And by changing those functions, those weights, and tweaking them, then it's able to accurately predict what the joint's located. And so that's what this picture is supposed to indicate. That each circle indicates a neuron, a little mathematical function of a neuron, and that each of those numbers are different weights. And by tweaking those weights, then you could actually have accurate results. And so the output of these convolutional neural networks is something called heat maps. And so heat maps, as you can see, is similar to when you have a heat gun and you point it to your house. Anything that was really hot or warm would be indicated as red, and anything that's cold would be indicated as blue. And so in this is a statistical way of visually seeing what predictions, I guess you could say, predictions. And so the convolutional neural network outputs these heat maps and shows where it predicts where a joint would be. And so taking the Sidney Crosby picture, you see on the left image, it's predicting where the ankle joint is. And so the hotter it is, or the higher probability it is, that's the color of red that's indicating it. And blue also indicates that there's a low probability of the joint. And so in order to, I guess, understand, so once the algorithm, convolutional neural network, is trained, so after taking a lot of images and then it understands where joints are located, then we can actually test it. And so this is what we've done to test this algorithm. And so we grabbed a lot of images that are from online, and we also had our own images as well. And from this corpus of images, we determined the center of the body, and then we scaled these images so that the convolutional neural network can understand it and take that information. And then from that information, we feed it to the convolutional neural network. It learns where the joints are, and then it makes a prediction. It predicts 16 joint coordinates from, it's like, for example, the ankles, the knees, the hips, top of the head, the bottom hip, head, just key important joints or limbs that we want to identify. And then we were able to take these joints and then map them onto the image that was tested. And so from these images, we were able to test using two different types of data. One of them is a corpus of images that we found online, such as the Sidney Crosby one, or just a video that we found from a penalty shot from Edmonton Oilers with the Dallas Stars a few years ago. And so these are our results. As you can see on the left side is the predicted joints and where they're located, and on the right side are the heat maps. So where the algorithm predicts that these joints are. And overall, it does a really good job. You can see that for the most part, it's able to understand where the wrists are, where the shoulder, even the elbows. If you look on the right ankle, where the blue line is, it doesn't quite exactly predict where the ankle is, but overall, it does a pretty good job. And so this is another example. Once again, a pretty good job. And this third one I thought was a really interesting one. You know, it's a Canadian hockey player, of course. It's good. But one of the things that I thought was really interesting is that if you notice the background, who they're playing against, the colors are very similar. And when it comes to computer algorithms taking video, it usually analyzes things by pixels, by colors. And so the more the background is similar to the foreground to the hockey player, the harder it's able to analyze certain things. And so that's exactly what happened in this picture. When you look at the right elbow, the algorithm doesn't quite exactly understand where this algorithm is. In fact, it thinks it's very similar to where the wrist is. And that's actually indicated, if you look at the heat maps, on the third and fourth column, the second last row, you can see that the heat maps are just, some of those heat maps aren't exactly red, they're more yellow. And so that is basically saying that this convolutional neural network wasn't quite sure where the wrist or where the elbow was. And so now applying this to video, these are some quantitative results that we received. And so we tested it on 20 images, and these are the results that we received. And so total, the average accuracy was 81.56%. And these are preliminary results. This isn't just, we tested on a lot of images. And so from these results, it's a really good start to understand how pose estimation can actually be done in hockey videos. And so taking this now to a video, this is a 10-second video. And like I said, this is from this was a penalty shot a few years back by the Edmonton Oilers. And as you can see here, for the most part, the legs are clearly mapped out. I'll play it again. And then at times, and for the most part, it does really well with the arms and identifying the shoulders. Sometimes the predictions are a little bit different or a little bit modified and changed because sometimes it's hard for the algorithm to see where the wrists and where the elbows are. I'll play it one more time. And that's sometimes due to, because, you know, looking from the video, you can't actually, even as humans, we can't actually see where the wrists are, where the elbows are. But at other times, it's because the wrists or the elbows are really close to the body, and because of the image colors, it's a little hard for the algorithm to see it. And so, what can we do with pose estimation with hockey videos? How can we apply this to the analysts, coaches, scouts, whoever you are, can actually use this? Well, there are three ways that I thought were very interesting and that can be applied. One of them is using action recognition. So as I said before, determining if somebody is shooting, somebody's standing still, somebody's doing a crossover, all these different things are valuable. So that way you can understand what a player is doing preliminary to shots. Or you can also understand what a person is doing at any time. You don't have to get statistics that are based on seasons or based on a game. You can figure out what a person is doing and how they are doing instantaneously. And so another part is estimating the speed of a player and evaluating techniques of the player too. And so, so from this paper, this is what we've done so far. when we wrote the paper, but we extended this a little bit, and I wanted to show you the results of actually implementing it using action recognition. And so this is what we've done after we've submitted the paper. And so to describe it a little bit, what we've done is we've done action recognition. So we've identified 4 different types of actions that a player would normally do. For example, if he would do straight skating, and that just refers to having both feet on the ice. Another one is doing your crossover when you're trying to turn. The other one is pre-shot when you're shooting and it's right before the puck leaves the stick. And the third one is post-shot, so you follow through. And then what we have done is we've taken 845 images. We've used the convolutional neural network previously done for the pose estimation, and we extended it to identify these 4 different types. And then from these results, we tested it 1,000 times. And the actual average, or the average accuracy that we received was 65.47%, which, just beginning, is a great start to understand how we can apply pose estimation in using hockey videos to analyze players. And so I'm really excited for these results, and I'm glad that I've been able to share with you guys. So thank you.
Questions for Helmut?
Have you tried putting your algorithm in with a motion capture system to see how accurate your body estimations are? So I guess give yourself a little more oomph for the reliability of your experiments.
So have I tried it on other data sets?
No, motion capture, like a Vicon system, where you track, you can do it on ice as well, but normally it's in laboratory and you track human movement, and that's the design of the system. But by taking that, which is actually proven to help, I guess, solidify your results, so that way having this tracking from a video is able to have a stronger correlation to an actual movement.
Okay, and those, like, usually that's usually like something similar to a Kinect where it has like depth sensors and so on and so forth?
Yeah.
Yeah, okay, well, the reason why we didn't necessarily want to go from there is because of the fact that usually those motion capture systems have depth sensors, and we wanted to apply it specifically to hockey, and we wanted to, some of the constraints that we wanted to work with was, you know, if we were ever to use this in production, we wanted it to be easy for hockey players, for analysts, for coaches on all levels of play to use. And one of those reasons was that you actually have to implement cameras into a hockey rink. And if you were to use something similar to like a depth sensor, the range on those at most are 20 meters, and the overall hockey rink is, you know, of course, significantly more. But that's something that actually what we're going to try to do next is take either motion capture data just to see how our algorithm actually works, or take other data as well when it comes to identifying actions from, you know, from the community. Thank you.
We've got time for one more. Yeah, go ahead.
Have you applied any of this work to other sports? Because I see it very useful probably in like baseball, for example, with pitchers and their mechanics, where their arm angle needs to be so precise, otherwise they're tipping their pitcher and that sort of thing. So I'm just wondering if you have applied it to other sports.
So far, what we have done is focus our time on hockey specifically, but one of our researchers is applying it to soccer specifically. And so we thought that hockey was a really good way to show how robust the system is, because hockey players have a lot of equipment on. And believe it or not, having a lot of equipment, it's harder for algorithms to identify a player. It's hard for people to identify different joints and ligaments. And so when you're a baseball player or even a soccer player, the algorithm is significantly much better, because all you're wearing is just shorts and socks and shoes. You don't have a helmet, you don't have any other gear or bulky sweaters or anything like that. And so far we've applied it to soccer as well. It significantly improves because of that specific thing.
Let's thank Helmut one more time.